Hi, Professor Bhavani.
Hi.
Hello.
Hello, good afternoon, good morning. Yes, good
Yeah.
morning.
How are you?
Yes, fine, fine.
Perfect,
Just
perfect, perfect.
I have to give the right share to you.
Probably yes. Okay.
Let me see
I think,
multiple point.
yeah.
Are you having those share right or not?
Nope.
Yeah.
I have host disable participant screen sharing.
Where is that one? Into, I think I have now authorized.
Okay. No worries. I will try. Let's see. Yes, I can. Okay. Give me a couple of seconds. Let me.
We have started recording as well because we need that
Yes,
lecture
yes,
for
yes.
our
Of course, Professor Bhavani. No worries. Absolutely no worries. Will be my pleasure to, how to say, to do again, to redo. So no worries. Let me just share everything. Okay. 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 Console tabs. Okay. So let's see. Okay, so Professor Bhavani, you have my presentation, am I right? From last time, or should I send it again to everyone?
I think I have a presentation.
Yeah,
But
I haven't, I
yeah, it
just
would
have
be
to.
better if you could send. We can keep it on portal. Yeah.
Of course. So give me 1 second. Let me send it to you. Okay. Presentation. So, okay. Okay. So I'm sending at Muet. Am I right? The email?
Yeah.
Perfect. Okay.
Mhm.
Okay. Okay. So let me share my screen. Okay, share, hopefully. Okay, so here it is. Okay, hopefully you can see my screen. Okay.
Presentation mode. It's not in the presentation mode at the moment.
Yes. I will put it on presentation mode.
Right.
Okay. Is it okay now?
Yeah, now it's perfect. Yeah.
Okay, so let me hide this one. Okay. So hopefully you can see it.
Yeah.
Okay.
How long? What would be the duration? It's within.
Wherever, how to say, I can do it as quickly or however you want.
Yeah,
In terms of,
maybe.
let's say, maybe 30 minutes. Is it okay? 30 minutes?
Yeah, within because we got that Zoom limit. That's why, So 30
Okay, so
minutes be
30
fine,
minutes,
I
30
think.
minutes.
Yeah. Or
30
25,
minutes, it's okay.
25 minutes to 30 minutes, I think.
Okay, agreed, Professor Bhavani. Okay, so I'll try then to 25 minutes. Agreed. Okay,
Right,
perfect.
right. So I think
Okay, so if
we got,
you,
yeah, we can start. We got, I think around 15 people, 13, 14, they have joined already. But the main purpose is recording because last time we got around 650 participants. So most of them are repeat and just it's or some of them might have missed. Some of them are new from computer system. engineering department. We got here Professor Dr. Shahnawaz Talpur. I don't know whether because I gave only video, right? Only I think yourself. So Dr. Shahnawaz, are you there? He's a director, a co-director IICT. We have got Institute of Information and Communication Technologies. He remained head of the Computer System Engineering Department for 6 years.
Okay, nice meeting you. It's a pleasure.
Dr. Shahnawaz, are you there? Professor Shahnawaz?
Yes, sir, I'm here, sir. I'm with you, sir. I'm here.
Okay, okay. Thank you, thank you. And
Perfect,
Dr.
perfect.
Pardeep, I don't know whether he has joined or not. He's supposed to join, but he's our team member as well from Quest.
Okay, perfect. So many people then. Okay. Thank you. Thank you for taking your time to, how to say, not only to have the presentation recorded, but also to, how to say, if any questions arise, please feel free to ask me. It is my pleasure again to make this presentation in front of such a esteemed group of people then, not only students. Okay, so wherever you give me the sign, Professor Bhavani, I can start.
Yes, just to share with good news that even yesterday, our partner Jikki Ghulam Isa Khan Institute of Engineering and Technology, they got approval of the curriculum through all their statutory bodies, and now we submitted curriculum. They submitted to our Higher Education Commission. So there was a deadline to start in fall. We have to submit before 31st March, so it has been submitted in time. And I got some project officer mail as well, and we will discuss. That's all positive, but we'll discuss. I think next week we have to have one online meeting for that one, the quick meet, a short meeting.
Yeah, please send me a link for the meeting. I need probably to share some information about the audit that we're currently how to say, we are audited by the European Commission. And from what I know, probably everyone will receive such how to say a letter for all the partners for auditing the project
that would
and
be
the project
very
development.
helpful.
Yeah, so I will share whatever information I have.
Right.
Okay,
So
perfect, perfect.
we can have, you can start your talk. So this
Okay.
Professor Agata from Technical University Sofia, our partner university, and she's working as a dean. So over to you, Professor Agata.
Thank you, Professor Bhavani. Thank to all the people that are participating in this online lecture. So my task for today is to give you a short presentation and to speak about real-time data integration with digital twins. So from shop floor to simulation. And my idea is to give you a presentation about how real-time sensor data from the factory floor feeds a live virtual simulation as a digital twin, why this is important, what are the current trends, what is happening in the research domain, and what is happening in the business domain also. So this is going to be my task for today. I have around 20 minutes. So hopefully I can cover a lot of things during these 20 minutes. So again, because we're talking about digital twins, so there is currently in the last couple of years, 2 or 3 years, this big trend about creating digital twins as a representation of real world objects or people even, or processes used to observe past, current data to simulate potential outcomes and to accelerate, of course, understanding of the processes, understanding and being able to predict for maintenance purposes, for optimization purposes. Again, Industry 4.0, now Industry 5.0, about smart manufacturing. Without digital twins, this won't be possible. So also I need, because my area of expertise is the telecom side. So I'm going to talk a little bit about the real-time integration links with the physical operations together with the virtual simulation. So my idea is that the digital twins currently are revolutionizing the manufacturing, the system analysis, the consumer services, the medical industries a lot, because there are some practical implementation of digital twins in the medical industry. So the value of the digital twins is very, very important, and they helped a lot to avoid critical mishaps in systems that are very expensive. They help increase productivity. So as I mentioned, the idea is by creating the digital twin is to simulate and to avoid a lot of problems and to speed up a lot of processes and, if possible, work in real time. So the traditional landscape is very, standard. We have a lot of sensors in the SCADA systems. So there are people, there are machines, they're working together, they are transforming materials into some finished products. So to manage the industry shop floor effectively is very crucial. So we can ensure smooth operation, maintain high quality of the product and the standards, and to achieve optimal efficiency. So the idea is that we have very, interesting challenges in terms of, as I mentioned, real time. So latency is a case. We have a lot of sensors, so being able to work on transformation of different types of data is also a challenge. Also, again, I will underline here that we need to have compatibility between sensors and to have distributed probably calculations and maybe fog computing or cloud computing. So we have rich data, a lot of data, but we need to be able to gather this data, to transform it on time, to bridge the gap between the machine, the sensors, and the processes. And this is where the digital twins come into, in their role. So this is an example, a shop floor design as a 3D representation that can help engineers to plan and visualize production layout in the shop floor of the company. So we have this digital representation. So we have a series of cutting-edge solution. The idea is to facilitate seamless machine-to-machine communication, and of course, integrate the people that are working inside in this process of creating, transforming raw materials to finished products, observing standards that are very high. So we need to take into account that. So what is happening? As I mentioned, my idea is more to look at the side of the telecommunication. So we have a very big development in the current mobile communication through the different options like networks like LoRaWAN, Zigbee. So these networks are dedicated for sensors. Where sensors distributed not only in factories, but also sensors can be installed in homes, smart homes, so smart cities. So we have all this information created with the goal to collect data from many devices and then transporting this data through the IT infrastructure and then have visualization of the different results, being able to predict, being able to prevent problems. So the main challenge here is real time, as I said, very small latency. Again, heterogeneous data processing. As I mentioned, there are a lot of sensors. And the idea is that this data from the sensors, which is very different from sensor to sensor, must be processed and must be analyzed, not only processed, but analyzed. And again, using different algorithms some predictions or some preventions must be taken into account, or have live diagnosis, as I mentioned here in this internet slide. So the idea here is that the current development in the telecommunication fields are some key protocols for communication, and the key protocols that are very important in the current, machine-to-machine communication is the protocol that is mentioned here is the MQTT protocol. I don't know if you're familiar. This is Message Queuing Telemetry Transport Protocol that is especially created with this goal to collect plenty of data from many devices. So, and most of the sensors that are produced currently support this type of communication using this protocol. Also, one of the protocols that is also very popular in the current telecom domain is the Open Platform Communication Unified Architecture, so edge computing protocol. And these are the most, used standard protocols in the telecommunication field to transport data reliably and securely from shop floor to the cloud, to have the processing done in the cloud, and then, as you can see here in the graph, to visualize, monitor, control, predict, of course, different variables in the process of manufacturing. So, what is the architecture of a real-time digital twin system? As I mentioned, I'm going to concentrate on that. So the idea of the architecture is composed of 5 interconnected layers mentioned here. So each layer has a specific function to ensure seamless data flow, synchronization, of course, of data, and interactivity. So we need to ensure interactivity between the physical and the digital realm. So the digital realm is about the digital twin, and the detailed breakthrough of each layer is, you can see here, we have the physical layer with the machines, the infrastructures, the sensors, the embedded devices, and we have to capture the real-time operational data to support the actuators that will react according to the effects of the digital twin, and to initiate the data pipeline. Then we have the communication layer. So the role of the communication layer is to have the reliable real-time data transportation to the cloud, of course, where we have different types of, as I mentioned, networks. Either you can use LoRaWAN networks, or Ethernet, or Wi-Fi, or 5G, 6G, future, etc., etc. The communication layer, as I mentioned, is based on the 2 very popular protocols, MQTT, OPSC. Of course, there are others that can be used. And this is for data routing, for protocol translation, to ensure very low latency, high throughput transmission, handles, edge to cloud transformation, and device to device communication. So again, also I need to underline, because probably there will be some questions. Again, here we ensure most of the security. So we have the encryption of data and data authentication. So then we have the processing layer, where we have, as I mentioned, cloud platforms. Like the previous slide, I have mentioned the Azure Digital Twin platform. There is this platform on Microsoft. Don't forget that there is also AWT, the Amazon IoT platform. There is also Google Cloud IoT. So there's a lot of platforms already that exist. There are data streaming and event processing systems that also are available, like Apache, Kafka, like Flink, etc., etc. So we have a lot. And again, the functions of this data processing layer is to filter, aggregate, pre-process incoming data, time series we have, anomaly detection we have, model inference we have. Again, we need to ensure here scalability, because this is a cloud computing. So computational efficiency. So we have a lot of processes happening in this layer. So the digital core layer is where the central model representation of the digital twin and logic exist. So here is where the simulations are done. So we have all the data coming from the communication, passing through the processing layer. We have in this digital core all the AI algorithms, so simulation engines, prediction models, and here the digital twin will help us with decision making and control logic. And the last, again, layer is the user interface, where we have the visualization and interactive element. So we can use here a web visualization or a mobile phone visualization or AR and VR interface visualization. So we can use here Unity to create more visual representation, or Unreal, of course, for 3D digital twins, but there are also Grafana or Power BI. So there are different platforms for 3D visualization that we can use. And again, this is for real-time monitoring, for visualization, for supporting of decision-making, from alerting. And again, the human here plays a key role, so he's part of the system. So, as I mentioned, my importance here of this presentation is the real-time integration. So the real-time integration will refer to instantaneously using the data that is gathered, making the data available on different sources. So either through the glasses, AR, VR glasses, either through a monitoring web interface. And we don't have to wait for, periodic updates. We need to see this immediately. So we have a dynamic workflow of information. And this is like, a movie, the Matrix movie, if, most of you have watched it, where you have this continuous flow of information, where you update, when you offer fresh insight each moment. And of course, you have a reaction from the actuators immediately. So whatever you're doing on the digital twin, so the digital side of the system, you can transform it immediately through an action on the shop floor. So this is something that is very important. So real-time integration means that the digital twin is always in sync with the real shop floor and not a snapshot from some past events. Okay, so we need information live now. Okay, so why it's crucial? Here I have mentioned a couple of very important elements why the real-time in digital twins is very crucial. So we need reliability. So if the digital twin is not using real-time data, this means it's just a very static model. So it's not accurate. And potentially, as I mentioned here in the presentation, it will become very quickly obsolete. Again, I will underline real-time decision-making. So if there are actuators on the shop floor, the digital twin will provide immediate information and action. And these actuators will, react immediately. For example, if you consider the Amazon intelligent warehouses, where people can link together with the robots that are currently working. So if usually the robots go on a certain way, so if there's a person on the way, the robot must react immediately, not to harm the person. So we need to spot immediately some anomalies, for example, or potential roadblocks, and the system must react accordingly immediately. So again, we need to have this predictive maintenance, to have some strategies, and this can be done only if we have real-time information. And of course, improved cooperation and communication between people that are part of the system. So they are central or in the loop of the system, and they need to communicate with the machines to make well-informed decisions on the system in the real life system. So what are the key components for a real-time data integration for digital twins? So we have the sensors here and the actuators, as I have mentioned before. So we have the IoT element. So we can have smart thermostats or advanced robots even, so they can actively monitor and transmit data. So this is the data transmission element. And we have the middleware where we have the platforms and tools. They are conductor of information, and we have this seamless communication and synchronization between all the instruments. Here, the data processing, the data modeling, and then we have the integration platforms, the message brokers, the API management, etc., etc. So we have a lot of things happening in the middleware. Again, here we have also the cloud storage or edge computing. So a lot of, as I mentioned, communication scenarios. And again, the last element is the software where we design, where we analyze, where we predict based on the information from these systems. Okay. So what are the latency issues and to ensure how to trust the data? So every millisecond counts, and it can make the digital twin misleading, the information. So to achieve real-time performance, this means that we must plan carefully the telecom network and the edge design. So this is very important, the processing speed. So once the data reaches its destination, again, latency can be introduced. And we need to also plan for network congestion. The only one that has a dedicated bandwidth are the military. So everything else must plan for network congestion, for high traffic and limited bandwidth. So this is, again, something that needs to be planned in advance. Again, there is a lot of data happening. As I mentioned, there are plenty of sensors. So each sensor measures its own data. And we have plenty of connected devices, and the infrastructure must be able to scale proportionally to handle this increased data flow. And again, we have some physical limitations because currently everyone is paying for, data storage, and it costs a lot. And there is a limitation of how many data centers can be developed. And again, processing power is a must because we have many models running on real time with vast data streams. So these are some dilemmas that we, as a developer of a digital twin that works in real time, must take into account. And the storage dilemma is a very big challenge, especially when we have video sensors that record not only, as I mentioned, images, but maybe video. So industrial environments generate millions, billions of data points daily. Infrastructure must be scalable, and it's essential how we handle the data without losing speed and accuracy. Data integrity is also very important. So what we need to take into account is the data veracity. So not all data coming in real time is of high quality. So erroneous reading from sensors is something that happens every day. From a malfunctioning sensor, you can get bad data, and we know that these results from a bad sensor can be deadly. Everyone remembers the airplane Boeing that fell down due to errors in sensors in reading data. So this can skew the analysis, and in this case, it was deadly for people. So data consistency is because we have multiple sources that we have sometimes doubling of the data. So we have conflicting or redundant data. So this will complicate the process and analysis of the data. And the third most important form is to ensure security of data. So data security threats are very, very real, and data streams are especially vulnerable to breaches or tampering and potentially compromising the data integrity. So digital twin cybersecurity practices must be adopted and must be taken into account. These are non-negotiable elements of the digital twin. So by integrating, creating a digital twin, we need also to think about, what already exists. So legacy, older systems. So how to help them, these systems, how to say, repair them if you want, or how to update them for them to be able to support real-time data flows. So this is costly operation, but also we need to take into account interoperability, because as I mentioned at the beginning, there are different time and different data formats. And again, working with real-time data is not an easy thing. Here I have mentioned some best practices. I'm not going to repeat, but for me, is very important to understand that not everything must be real time. We need to determine which elements must be, which type of data we must keep real time. Some of them can be processed later, for example, in batches. We need to reduce also data redundancy by merging or aggregating similar data streams. So these are things that can be planned in advance to have an effective real-time integration with what we have. So this is some telecom information about utilizing standardized data formats and protocols. This already exists, and this standardization ensures that every device that we have integrated as an information flow in the digital twin, every platform and every system will speak in a common language and will help the digital twin understand what is happening. As I mentioned, there will be some, security elements. I'm not a super expert in cybersecurity, but these are some general things that needs to be considered when creating the digital twin. End-to-end encryption, of course, is a must. Authentication protocols are a must, and continuous monitoring of the data and looking for anomalies also is a must. But thanks to machine learning algorithms, this is facilitated a lot. So we have a lot of helpers now with different AI agents that help us monitoring in real time the data. So let me see what else, because I have like 4 minutes. I want to underline some interesting elements for the decentralization of data processing, that the cloud computing is helping us a lot to reduce the bandwidth strain, where we can decentralize the data streams and less data can be transmitted over the network, so we can preserve bandwidth for crucial operations. A lot of technologies, as I mentioned, exist. These are some examples that I have found, and you can, look if you want. But the most popular are mentioned on this slide: AWS, IoT Greengrass, Azure Digital Twins. There is also Siemens. Some of them are open and can be used. Some of them are proprietary of different companies. So yeah. About simulation and modeling, some examples, and of course about data streaming servers. I have given you some examples here. So it's an ecosystem with a lot of options that either you can choose about a specific, as I mentioned, vendor, or you can create your own open source digital twin. So how it's evolving? Of course, every day is moving around. We have a lot of AI now, a lot of models that can help us create, enhance, and personalize according to the application. So we can predict failures, adapt autonomously, and personalize insight for each operator. So visualization is my forte, because I work a lot in virtual reality and augmented reality. This is something that will happen, and we will see how now most of the vendors like Meta, for example, are already offering on the market cheaply for around $200. You have AR glasses that you can transform and see much better the data as an immersive and more comprehensible model. And this helps a lot of industries like architecture, urban planning, et cetera, et cetera. So let me see what else, because I have a little bit more time. So these are some future trends. You can see autonomous operation, like self-healing production lines. Something that will be very important, again, is Industry 5.0 and the human-centric digital twins, using AI to help and adapt the environments with human workers, not just replace the human workers. So this is something that will happen. And these are some examples about, companies that currently have created digital twins running in real time at a scale. There are some cities that have created their own digital twins. There are some healthcare companies for diagnosis and treatment. There is Tesla factory, there is Siemens, there is Vodafone. So all these manufacturers have created real-time digital twins that can be used and are very, very, convenient. So this is briefly my presentation. I see that I have 1 minute still in my, time.
Thank you very much, Professor Agata. I think if we get disconnected and they can join with the same link, we can join. If there are any
No
questions.
problem, Professor Bhavani. I will try to join again, of course, for questions.
Right, and let me see.
So I will stop sharing.
Professor Sharna was there. If I invite him, where is that one? Hello, participants to.
Sir, I'm here, sir.
Okay, you are there. Okay, right.
If you have any questions, you can contact me also by email. I'm seeing a question. How will digital twins evolve in the next 5 to 10 years? Can digital twins contribute to sustainability? Okay, so thank you for the question. I think there is, a lot of work to be done. In terms of sustainability, what we're currently working on, most of the digital twins, is how to preserve energy, how to be more efficient with less resources. And if you look at, for example, the plans for the digital twins, is to be able to create digital twins of people, to be able to customize, medical treatment according to the reaction of the digital twin. So there is a lot of things that are coming in the future. And obviously, the main goals are to facilitate our lives, but not only to facilitate, but also to be able to use less resources, to be more green, to respect the environment. My, question here is because we currently employ a lot of cloud and edge computing and a lot of AI agents. So we need to find a very good balance because everyone is looking and seeing that the AI centers consume a lot of energy, consume a lot of water, so a lot of resources. So this is we need to find the balance between, what we create and actually the resources that what we created is using. So this is something that I can give from my point of view about sustainability and what will happen in the future. Digital twins will continue growing, will get very easily accessible. Everyone will have the opportunity to create and to do something. The idea is, as I mentioned, by doing that, what resources are also being spent, even though if we don't think that each query in ChatGPT costs something in terms of resources, but the progress is there and it will continue. So we, as researchers, as students, we need to find balance between that.
Hello, Professor.
Yes.
I have a question. Thank you first of all, thank you so much for this wonderful presentation. So my question is that right now I am a master's student at Mehran University in IT department. And currently my research, I just completed my thesis and the topic is about solar eye. So the concept arises from combining the vision model and the thermal model prediction. So both can predict at a time by combining the power of those both models. So can it comes, or we can say this is about digital twins, like combining, checking the solar panels condition, the dust condition, whether they're having the dust layer or not, and then predicting the ground truth with the help of the temperatures and other data, which I got from somewhere and I trained the model. So that is predicting parallelly the temperature or the heat gain, or we could say the microclimate change it is impacting. So, but what I got and what the problem I faced was about the data. I couldn't find any kind of data in Pakistan regarding that, like the solar panel module temperatures and the ratings and all about these one, and also the permission and legal issues regarding the drone and using those drones for a nearby measurement of solar panels conditions. So these issues arises. So how we can overcome these kind of issues at early stage in developing countries like Pakistan. And yes, I would like to add that Dr. Shanwaz is my supervisor in this project.
So the topic is very interesting. Congratulations. Okay, so data is a problem everywhere. So I can tell you that it's not only Pakistan. Same thing probably will happen here with the student in my university. So usually when we try to solve this type of problem, so first data, when we have such a practical and this is very practical, very interesting topic. Usually, we try to find a company that is working in this type of domain, so if possible. And then with collaboration of this company, we try to, get some data that can be shared. The company benefits because, they have a student with interesting point of view, with interesting topic that may be of, how to say, help them in the future. So usually we receive a positive, answer for data sharing. And about the drones, same thing here. You cannot, how to say, operate without permission, and you cannot get data from the drone without permission. So there are certain steps to pass before getting this permission. At least from the Bulgarian point of view, I know that getting permission is not very difficult. So there are some standard organizations that you need to pass a certain test to get a certificate that you are allowed to, to use the drone and go for a certain height, with this drone. And then if you have the company which you work together with, they can allow you, for example, to use the drone on, over their solar panels to get some data and stuff like that. So, probably same thing in Pakistan. Obviously, you cannot use the drone around critical infrastructure and stuff like that. But if you have the permission of the company and you work together with the company, usually this is a document between the university and the company that you sign, that they allow you certain things to do under supervision, of course, of some employees of the company. So my recommendation is, if there is a company in Pakistan, 1 or 2 or 3, probably you can try to find a communication, offer them, this is my project, this is what I'm doing, these are my ideas. Would you like to, combine our efforts? Of course, I will provide all the information to the company, so they will have, the access. Or you can see if you can devise something that maybe, a patent or a model will arise from your work, or something that you can benefit you as a, how to say, a master degree student. As I mentioned, it's a very good cooperation between business and academia. If this is, and probably this is supported by your university. But in this case, you with your advisor must take the proactive role to find your business collaborators in terms of companies that can give you access to this type of data. But as I mentioned, it's the same thing all over. Bulgaria is yes, we are part of the European Union, but in terms of development, we, together with Romania, are much, much less developed than the rest of the EU. So, as I mentioned, very, very similar challenges as with Pakistan. We're not so different at all. But we are much smaller.
Thank you so much, Professor. But I got the solution by just retransferring the data approach from Bangladesh. There was a data set I used and just applied that approach. So that approach can be mimicked and reapplied if the Pakistan has a data set of such kind. So I got the equation and I solved on some standard, which was the standard value and coefficient that was predicting the heat gain. So
Perfect.
until that, thank you so much for this explanation.
Perfect. Okay. Thank you. Thank you.